Math 265A, Quest to College, I'm Joe Vasta. This is Review 2. So let's get to some problems. So for a few of the problems, what I'm going to do, maybe the first 3 problems, we are going to compute the derivative f prime using the definition. Okay, your book says use limits to find, so I'm going to break the exam problem into 2 parts. So we want to know how to find or compute the d cubed, but also simplify it as well. Simplifying the d cubed is the process of doing that is canceling that h that's on the bottom of d cubed, and well, let's just jump into it. So part A, d cubed is the definition of the difference quotient f of x plus h minus f of x all over h. Okay, so I'm going to go ahead and put x plus h in for x. So I have x plus h squared plus 2 times x plus h plus 9. Now, it might be worthwhile, every problem I put up, if you were to pause the video and see if you can get the answer, and then play the video and see, you know, if our answers match. So this right here is this part. Okay, and then we have a minus sign, which is what you see right there, f of x. So here's x squared plus 2x plus 9. Oh, by the way, we already know what the derivative is going to be, 2x plus 2. Now, we don't know what the difference quotient is going to be, and that's what we're figuring out. And we're using the definition. So this is a standard requirement in a calculus class. Don't think that I'm doing this just to be mean. I'm supposed to test you over the definition of the derivative. This is all over h. Okay, I'm going to go ahead and FOIL this out. This is x plus h times x plus h. So I have x squared plus 2hx plus h squared. I'm keeping it alphabetical there. Yes, I could write 2xh, but I decided to keep it alphabetical because then I can combine like terms more efficiently. Distributing the 2x plus 2h, and then the 9 is there. Then I'm going to distribute that negative, minus x squared minus 2x minus 9. This is all over h. Let's go ahead and combine like terms. This happens a lot when you're doing the difference quotient, where things will cancel, like the x squareds cancel, and the 9s, they're out of there. What else? Well, the 2x's. And you only have 3 terms on the top. Those 3 terms on the top, they each have an h in them, so I'm going to factor out an h. Factor an h out of there. We have 2x plus h. Over here is plus 2. This is all over h. And what happens to those h's? I have 1 term on the top now. I used to have 3 terms. Now I have 1 term on the top and 1 term on the bottom. The h's cancel. My dq is 2x plus h plus 2. And we'll box it because that is the answer to part A. Part B asks us to use limits to find the derivative, and we take the limit. So here's the derivative of your function. You take the limit as h approaches 0 of dq. I'm not going to write up dq again, and I'm just going to plug h equals 0 in there, and I end up getting 2x plus 2. And so we've completed computing the derivative using the definition of the derivative. Let's go ahead and do another problem that's very similar. here's one that has a fraction in it. So go ahead and pause the video. See if you can do this one on your own. The directions are compute and simplify DQ. And then part B is use limits to find the derivative. Okay, we call this function g of x. Now, I forgot to tell you on the last one it says RE. RE stands for review exercises. And so I just pulled this and problem number 2. You know, that's why I didn't explain it correctly. You know, I just assumed, okay, we're going to do a problem, but it says problem number 2, and this is in the review exercises at the end of the chapter. And so when I put RE, review exercises. So go ahead and see if you can do this one. Part A, DQ equals, okay, this is g of x, so I'm going to write it as g of x plus h minus g of x all over h. Okay, g of x plus h, I put x plus h wherever you see the x. So I have 1 over, this is x plus h squared plus 5. So this first part, we'll color code this, is that part right there. Minus sign, minus sign. G of x. So g of x is just this guy right here. 1 over x squared plus 5. And this is all over h. And I'll color code this one here. Okay, so the next thing that we're going to do is we want to get a common denominator. Now look at this. This does look a little scary here. So we could multiply this out. In fact, that's what I'll do. I'll write this as 1 over x squared plus 2hx plus h squared plus 5. Then we have minus, I'll leave a lot of room here. Then we have 1 over x squared plus 5. This is all over h. Okay, the common denominator with the top fractions would be this guy right here times x squared plus 5. So I'm going to put an x squared plus 5 on top as well. Okay, common denominator, we get the same thing. This one's going to be, that needs parentheses, x squared plus 2hx plus h squared plus 5. And I multiply top and bottom by that same thing. Okay, so now what I'm going to do is I'm going to go 1 times that. So the top of the top fraction is x squared plus 5. Then I'm going to distribute that negative sign to all 4 of those terms. So I have minus x squared minus 2hx. You see, I'm just looking at these right here, and then minus h squared, and then minus 5. This is all over this guy right here, x squared plus 2hx plus h squared plus 5. And then this is x squared plus 5 all over h. It looks like I'm going to need another piece of paper. Before I move on to the other piece of paper, let's look at the numerator of the numerator, or the top of the top fraction. The x squareds cancel. What else happens? Well, the 5s are out of there as well. Okay. So move this up a little. Good thing we have shortcuts for derivatives. Not for these problems, but you know, from now on after this exam, you can just use shortcuts. I'm going to do copy dot flip because the fraction on the bottom is h over 1. So copy the top fraction. It's a lot of writing here. I don't know if this is awkward silence or what. Okay, so there's the copy, dot, flip. Okay, so we'll move this up a little. Now the top, right here, this numerator, we can factor out an h. Some of you might argue, hey Joe, factor out a negative h. Tomato, tomato, it doesn't matter to me. I have negative 2x minus h. And on the bottom, I have the h times this, so I'll put the h right there. We have x squared plus 2hx plus h squared plus 5. This is getting tiring to write each step. Now look what happens. We have one term on the top and one term on the bottom. So I can cancel those h's. So my difference quotient would then be negative 2x minus h, that's on top. And on the bottom we have the thing I've been writing in every step, x squared plus 2hx plus h squared plus 5. And then this is x squared plus 5. This right here is the difference quotient, dq. It's the difference quotient of a function that was called g. So part B, what they want us to do is find the derivative of g using this definition here, using limits. The limit as h approaches 0 of dq. Okay, well think about this. The places where you see the h happen to be right there. That's going to be 0. And those two terms within those parentheses, those are going to zero out as well. So you'll have a negative 2x on the top. And on the bottom you would have what? X squared plus 5, because those h's are 0, and then you have another x squared plus 5. Of course, we have to simplify the bottom and write that as x squared plus 5 quantity squared. So our final answer is negative 2x all over x squared plus 5 quantity squared. So that is the answer. Now, when you think about it, look at this. If they just asked us on the test to take the derivative of this, well, we would just do the quotient rule, and it would be a lot faster than this. But on the test, if they say compute and simplify the dq and use that to find the derivative, you have to do it this way. So, you know, this is just sort of what is asked on many calculus tests. So would you be able to take the derivative of that if they didn't ask the definition? Why don't we go ahead and do that? I wasn't planning on doing this, but I think it's actually a good problem to do. So let's just write up this problem. We have g of x equals 1 over x squared plus 5. And then maybe the directions are use shortcuts to find g prime. Okay, and when I say shortcuts, you know, on the test I might not say shortcuts. I might, if I just say find the derivative, then use the shortcuts. But if I say find the derivative and dq is involved, then do what I just did. So see if you can pause the video and use the quotient rule to get this problem done. Okay, the quotient rule. So there's the top, there's the bottom. I'm using the quotient rule. There's going to be another way of taking care of this problem when we learn something called the chain rule later on, but right now we don't know the chain rule. Okay, the derivative of our function is the derivative of the top times the bottom minus the top times the derivative of the bottom, which is 2x. This is all over the bottom squared. Okay, so what do we have on the top? Minus 2x. And on the bottom we have x squared plus 5 squared. So look at the other one that took us 2 pages to get. It's exactly the same answer. Look at that. So we love the shortcuts. If we didn't have shortcuts for derivatives and we always had to use the difference quotient and the limits, I think I wouldn't be teaching this class. In fact, I probably wouldn't have become a math major. Let's go ahead and do another problem. So review exercises number 4. Here is a problem that we would not be able to do because this would require the chain rule. We wouldn't be able to do this problem using shortcuts yet. So the only way we can do this is the DQ, and so it's the same directions, compute and simplify the DQ, and then use limits to find the derivative for part B. Now there's a problem here, and the problem is that is an h of x. And there's not, I mean, it's not a huge problem, but my difference quotient has an h in it. So let's just go like this so we don't get too confused. Some of you would be able to handle that. Let's just call it, you know, and it says h of t actually, I said x. Let's call it f of t. So I'm relabeling the function just so we don't get confused with the h's. And here's part A, find dq. So you might want to pause the video and see if you can do that on your own. Okay, dq is f of, so we are going to use t's instead of x's, so t plus h minus f of t, this is all over h. Okay, f of t plus h, so I'm going to put that t plus h into the function, 3 t plus h, and then we have plus 5. So this part right here, the yellow part, is this part right here. Okay, I have minus f of t. So we have minus this guy right here. And so there's the minus sign. We put the minus sign there. Here's f of t, which is that guy right there. This is all over h. Okay, let's go ahead and distribute the 3 there. This is the square root of 3t plus 3h plus 5 minus the orange part, 3t plus 5. This is all over h. Now with the difference quotient, the idea is to let h approach 0, and you would end up having a 0 on the bottom and then also a 0 on the top. So to simplify difference quotient, we want to cancel the h, but we can't cancel it right now. What we're going to do, and this is the one that some of you don't like seeing, we are going to multiply top and bottom by the conjugate of the top. So it's like we're rationalizing the numerator. So I better leave a lot of space to do this. So this is square root 3t plus 3h plus 5, and then this is going to be plus, okay, so that's a minus there, and this will be a plus, square root of 3t plus 5. Okay, and then on the bottom I try to write the same thing here. Because really, what am I multiplying this fraction by? I'm multiplying this fraction by 1. Because this is the same thing over itself. When I was a math student, I hated when the teacher said that. Oh, we're just multiplying the fraction by 1, and I'd look at the board and say, I don't know about that. Okay, so the reason we use the conjugate is because when you do a FOIL, the inside and the outside term will cancel out. So I'm just going to do the first term and the last term. The first term is just going to be square root of that stuff times the square root of that stuff, which is really that stuff. And the last term is going to be a minus times a plus, which is minus root 3t plus 5 times root 3t plus 5 is 3t plus 5. This is going to be over the bottom. Now I don't want to write out that bottom, so I'm going to write bottom. Okay, knowing that the bottom is h times the green stuff. So on the top I have 3t plus 3h plus 5 minus 3t minus 5. This is over the bottom. So on the top, the 3t's are out of there, and so are the 5 and the negative 5. That's out of there as well. So another piece of paper, put that right there. We are going to say this equals 3h. Now it's time to write the bottom. So this is h times the square root of 3t plus 3h plus 5. And then we have plus the square root of 3t plus 5. With parentheses around that. So there's one term on the bottom and one term on the top. The h's cancel. And so our difference quotient has a 3 on the top and this stuff on the bottom. I'm not going to say it, I'm just going to write it. So there's the difference quotient. Okay, our function, we renamed it f. So part B, what they want us to do is use limits to find the derivative. So this is going to be f prime of t is the limit as h approaches 0 of the difference quotient. Okay, so if I put a 0 in for h, there's only one place where I see an h, then I end up getting 3 over root 3t plus 5 plus root 3t plus 5. So I have two of these creatures here on the bottom. It's almost like if I had a w plus a w would give me 2w. Well, I have this creature plus this creature gives me two of those creatures. So my final answer is going to be this. 3 on the top, 2 of these creatures, which happen to be root 3t plus 5. And here's the derivative. Now at this point, we don't know how to use shortcuts to take the derivative of our original function, which was root 3t plus 5. But after the chain rule, we'll know how to do problems like that. Okay, no more definition of the derivative in this review. I think we've done enough of that. And so I'm going to the review exercises. That's what the RE stands for. And this one says find the derivative. Here's the function. Go ahead, pause the video. This should only take you like less than 30 seconds. Okay, so here it is. The derivative is y prime. This is 2/3 times. Okay, the 3 jumps down. We have x and then squared. That takes care of the first term. On this one, we have a constant pi, and the 2 jumps down, x to the 1. The derivative of 7x is just 7. And the rationale behind that is the 1 jumps down, 1 times 7 is 7, and then x to the 0 is 1. Hopefully you've done enough homework where you feel comfortable with the derivative of 7x equals 7, and the derivative of a constant is just 0. So let's clean this one up and be done with this problem. So my final answer then will be 3's cancel, 2x squared plus 2 pi x plus 7. So there is the derivative. Let's go ahead and do our next problem. This is from the review exercises, number 14. Now we can't just do all the review exercises because we stopped in 3.6. So a lot of the review exercises will involve things from 3.7 and beyond, like the chain rule. So I had to actually be careful when I picked out problems for this review. So here we have this right here, and we're supposed to take the derivative. So we can use the product rule and say here's the first part, here's the second part. Or we could multiply the x through and then use the product rule on part of it and then not on the other parts. So you can pick how you're going to do the problem. I would pause the video and see if you can do the problem. And here it goes. I'm not going to multiply through. I'm just going to go ahead and say here's the first part, here's the second part. The product rule says the derivative of a product is you take the derivative of the first. So I'll put parentheses around this. So this is 2 times the second. Plus, I'll put parentheses around the second part as well. The first times the derivative of the second. Okay, the derivative of x to the 3/2. Well, by the power rule, the 3/2 comes jumping in front. Then you have x, and then you go 3/2 minus 1 or 3/2 minus 2/2. That's going to be 1/2. Okay, so now we'll continue. This is 2x to the 3/2, and then plus, I'm going to go ahead and distribute this guy into these terms here. So the first one, the 2's are going to cancel, and I'm going to have 3x and I have an x to the 1 there, times x to the 1/2. So you add the exponents. This is 3/2. And then I go ahead and multiply this. This is going to give me minus 9/2 times x to the 1/2. So I do have like terms there. I have 2 of these creatures plus 3 of these creatures, and then that's not a like term. These guys are. So I'm going to have 5 of those creatures. 5x to the 3/2 minus 9/2 x to the 1/2. And that's a good answer. Now, I suppose you may be doing your homework and you hit something like this and then you look at the book. Now on the test this won't happen because you're just taking the test, but if you look at the book, and then you look at their answer, sometimes this is very frustrating. And they get something like that. Okay, that's just them showing off. The book sometimes will do this because they feel like too many people are going into the sciences and math, and so they'll do this just to discourage people. Really what I have is they factored out an x to the 1/2, which is really a square root of x. And when you do that, you'll end up getting 5x minus 9/2. So that's what the book did. And so that's acceptable as well on the exam. So that is problem number 14 from the review exercises. Let's go ahead and do problem number 17. So pause the video, see if you can find the derivative of that function. Okay, so this one has some trigonometry in it. Looks like I have a product here. All right, I'll consider that to be the first function, and then consider the sine t to be the second function. So it's going to be like the last problem in the sense that I'm doing a product rule. The only different thing is there's some trig there. So the derivative of our function of this product, you take the derivative of the first times the second plus the first times the derivative of the second. The derivative of the sine is the cosine. And too bad I put parentheses, because if I didn't, I'd be able to box my answer. Okay, so we really don't want to have unnecessary parentheses, so this is 10t sine t plus 5t squared cosine t. There's your answer. And of course, the book would probably factor out a 5t and do some trig identities or whatever, but this is a good answer, so we'll keep it right there. Let's continue doing problems from the review exercises. Take the derivative. Okay, so I'm going to be taking the derivative of this. Looks like what I have here is a quotient. So when I have a quotient, I'm going to use the quotient rule. Here's the top. Here's the bottom. Okay, so we'll talk this one through. Well, first of all, hopefully you'll be pausing the video and trying to do these on your own. Okay, derivative of the top. 8u plus 1 times the bottom, 8u plus 1, minus, that's part of the quotient rule, the top, 4u squared plus u, times the derivative of the bottom, which is just 8. This is all over the bottom squared. So if you think life is bad when you're doing this, just think back to the definition of the derivative if you had to do the difference quotient, and then, I mean, that would just be a mess. So as bad as this is, it could be a lot worse. So we have y prime is, I'm going to go ahead and simplify the top by multiplying that all out. So 8u plus 1 times 8u plus 1 is 64. U squared, I'm doing a FOIL. I'm putting the outside and the inside together, so this is going to be 8u and 8u, so that's 16u plus 1. And then I'm going to multiply this guy right here by negative 8. Okay, so I know that's pretty tricky, isn't it? So negative 8 times 4u squared is negative 32 u squared. And negative 8 times a u is negative 8u. This is all over the bottom. Okay, so y prime is, now I'm just combining like terms, and when I combine like terms, I put my u squareds together, so that's 32 u squared. Where did the 32 come from? I went 64 minus 32. And then 16u minus 8u is 8u. And then we have plus 1. This is all over 8u plus 1 quantity squared. Now, are there factors of 32 that add up to 8? 1, 32, 2, 16, 3, no. 4, 8, 5, 6, 7, 8. No! So the top does not factor. You know, some of you might have thought, oh, maybe the top factors and something cancels with the bottom, which you should always consider that. But in this problem, the top does not factor. And you've got your answer. Let's go ahead and do another quotient rule, but a quotient rule that involves trig. Now I'm actually taking this from an even problem in 3.5 because I thought this problem looked really good for the review. Go ahead and see if you can do this problem. Okay, so you may have noticed that when you do the quotient rule, you identify the top and the bottom, you notice that the top has a product. So let's go ahead and take the derivative. So the derivative of the top happens to be, we'll need a different color, maybe I'll use orange. So you're doing the product rule. So the orange part is the product rule. And the red part is the quotient rule. Okay, so the product rule says the derivative of the first times the second plus the first times the derivative of the second. That's the product rule. Okay, big picture is the quotient rule. The quotient rule says the derivative of the top times the bottom. Minus the top times the derivative of the bottom. The derivative of 1 is 0 and the derivative of cosine is negative sine. This is all over the bottom squared. Okay, so we have the top to simplify. I'm going to do a FOIL because here's a binomial here and a binomial here. Maybe we shouldn't call them binomial. Here's an expression with two terms and an expression with two terms because they're not really polynomials. But I'm still going to do a FOIL. First, sine x times 1. Outside, this is plus cosine x, sine x. Put the cosine first for some reason. Inside, plus x cosine x. Last, plus x cosine squared x. Okay, over here I have two negatives which make a positive, plus, and then we have x sine squared. This is all over the bottom. We have that right there. Okay, so what do we have on the top? Well, we have some stuff that we probably want to take care of here. Let's see what we have. The first thing that I see is this part right here. When I see a sine squared and a cosine squared, it makes me wonder, like, oh, well, that should be an identity that I know. So I have a sine x plus cosine x sine x plus x cosine x. And then this one right here. Okay, so let's just see what we can do. We'll do this in green. On this part, you could factor out an x. And so this gives me a cosine squared plus sine squared. And does anybody remember what cosine squared plus sine squared is? That is 1. So I end up getting an x right there. This is all over 1 plus cosine x. So I actually forgot to put the squared there. And so going on to the next piece of paper, which is actually I have lots of pieces of paper. Look how many terms I have on the top. I have 4 terms on the top. Okay, so this is like a weird thing. It doesn't always happen. But sometimes when you have 4 terms, you can factor by grouping. A lot of you are going to cry when you see me do this because you're going to be like, no way. Look at the first 2 terms. What do they have in common? They have sine x. So I'm going to factor a sine x out of the first 2 terms, and then I'll have 1 plus cosine x.
I take this plus here and put it right here. And now what do the second two terms have in common? They both have an x in common, so I'm going to factor out an x. We have cosine x plus 1. Of course, this is all over the bottom. And so you can see that this is, I'm going to write out a step. Whoops, that's sine x. 1 plus cosine x. And then over here we have x, and I'll rearrange those terms. 1 plus cosine x. This is all over the bottom. And now I have two terms on the top, and they each have a 1 plus cosine x in common, so I'll factor that out front. 1 plus cosine x. And then this one is sine x plus x. This is all over. Now let me write out the bottom. 1 plus the cosine x quantity squared. So you can see, I mean, not only did it factor by grouping, which doesn't usually happen, but it factored by grouping. It gave us a factor that would actually cancel with the one on the bottom. So it's always worthwhile trying to see if your rational expression does reduce, and this one does. That cancels with one of those. And so my final answer happens to be sine x plus x on the top, and on the bottom I have 1 plus the cosine of x. And so there is the answer. Let's go ahead and do the next problem. I'm going to actually take another problem from 3.5. This one was actually, someone actually emailed and asked this problem, and I thought it was a really good problem to illustrate something that was not shown in lecture, and we're going to show it here in the review. So there's a lot of different things, a lot of different angles that we can do with this problem. There's a lot of things we're going to say about it. So let's go ahead, take the derivative of this problem. Okay, the first thing that I'm going to do is I'm going to realize, oh, I better do the product rule. Okay, the product rule says the derivative of the first. Now when I do the product rule, within here, there's another product rule. So it's like a product rule within a product rule. And so let me go ahead and do this product rule in blue. So the derivative of the first, that's the big picture. So I'm doing the derivative of x cosine x. So in here I'll say the derivative of the first, which is 1, times the second, plus the first, which is x, times the derivative of the second, which is negative sine x. Okay, so that was this little product rule here. So now let me go ahead and do the big picture product rule, which says the derivative of the first, which we already did, times the second, plus the first x cosine x times the derivative of the second. The derivative of the sine x is the cosine x. So let's go ahead and multiply things out. We have the sine x times the cosine x, which is the cosine x sine x. And then we have, over here we have x times a negative sine x times the sine x. This is going to give me negative x sine squared x. And then over here is going to be plus x cosine squared x. Now, I do see a sine squared and a cosine squared, but this one has a negative, this one has a plus. Your book, when they write their answer, they're going to do some trig identity on there. I'll come back to that. But right here, this here is acceptable. Now, let me go ahead and show you something that we didn't cover in the lecture just because sometimes I wait for it to come up in the homework. So this was a product rule within a product rule. We could have looked at this problem like this. F equals, that's not F, that's Y. Y equals F, G, H. Okay, let's actually back up a little and write out the product rule. So if you have just a regular product, the derivative is the derivative of the first times the second plus the first times the derivative of the second. I did 2 applications of that up there. But this right here, this problem is really x times cosine x times sine x, which is a product of 3 factors. And notice, look at this. If you take the derivative of just the first factor, which is x, okay, so let's think of this as 3 factors. That derivative is 1, and then the other 2 are just left alone. So if you want to take the derivative of a triple product, there's a more generalized product rule that says you go F prime G H, and that's exactly what this is. Now, the next one is going to be you leave the first one alone and the last one alone and take the derivative of the cosine, which is negative sine. So that's going to give me a sine squared, an x, and a negative, which is this right here. So look at this. This is plus F G prime H. And then you could guess that the next one would be F G H prime. And look at that. Leave those alone, and the derivative of the sine is the cosine. So you have x cosine cosine, which is x cosine squared. So this right here is the product rule for a triple product. And it's kind of easy to remember. You can generalize it to if there's a product of 4 factors, each of the factors gets a spank. And you're like, whoa, he said spank in the math class, but that's, look, whack. That one gets hit first, and the other 2 are just sitting there laughing. And this reminds me of my childhood. I have 3 brothers, and sometimes we all got in trouble. And my dad was a belt man, so I just remember, like, he'd take turns on us when we all got in trouble. And I remember the first guy would get, you'd want to be the first guy. So, like, when you were done and you were recovering, the last guy's still getting it, and it's kind of funny. And so that's kind of what's happening here. Shared a little too much of my childhood with you. So look at this, F prime, and those guys are like, and then look, now it's G prime, he's getting whacked, and F and H are just like, oh man, F's like, I'm glad I'm done with that, and then look, H gets it last. So that is the triple, what is that, triple product. And if you didn't know the triple product rule, you can do it the way we did it, where you're doing a product rule within the product rule. We've done a product rule within a quotient rule, and that, I mean, we dealt with that, and so we were able to deal with this. But now that we know this, you know, maybe next time if you see one of those in a technical class, you can do it that way. And with the analogy I gave you, some of you are like, I'm never gonna forget that. So, what does your book do? Okay, we've got our answer here. What your book does is they say, oh, well, obviously, we should keep going. So let me go ahead and first say this is what the book did, because this was a homework problem and someone had a question on this. And so I guess what can we do with this? We have a cosine, sine, and then we have these guys right here. Okay, so one identity that I think they're using is this one right here, which says sine 2x equals 2 sine x cosine x. So that's one identity they're using. And another identity your book could possibly be using is one that has a sine and a cosine. So I think it's this one right here, the cosine 2x equals cosine squared x minus sine squared x. Now, by the way, this is good enough for the exam, this one right here. It's not like, you know, any fraction's going to get reduced anymore. So take a look at this. This says cosine sine. You have a cosine sine here. I know it says sine cosine. And so this first part can be replaced with a sine 2x over 2. So I'm going to do that. Okay, so that's that first part. The second part, what I'm going to do is I'm going to factor out an x. So I have plus x on this part right here. So this is going to give me a negative sine squared x plus cosine squared x. And isn't this right here the identity? It's cosine squared minus sine squared. That's what we have here. And so then we continue here. We have 1/2 sine 2x, and then this is going to be plus x, and we replace this with the cosine 2x. So this is the book's answer. This right here is good enough. And remember what I said, sometimes they'll do things in their answers because they'll say there's too many math majors, there's too many people going into the sciences, so let's go ahead and throw some trig identities and make our answer look like that, so that when they've done all the hard work, they look in the back and their confidence is shattered. And they just do it slowly, slowly, slowly. It's the drippy faucet, and after a while people say, that's it, I am becoming an English major or whatever. So don't worry about this, but I mean, some of you would like to know, where did the book get their answer? It's because they were like, hey, let's do a bunch of trig identities. They have nothing better to do than psychological warfare. And there it is. Let's go ahead and do another problem. So where are my problems? So I think I'm going to pull one from 3.4. Here's 3.4. So look what we have here. I'm going to also make sure that the camera is still running. I've had some issues with this, the camera turning off and me not hearing the beeping noise. Okay. So, yep, I have 73 next. Okay, so, but it's going to be from a different section. So 3.472, find the derivative and the second derivative of this function. And basically, this is just doing two derivatives. But you have to know how to find first derivative, second derivatives, and even third derivatives, but we're just going to ask for the first two on this one. So go ahead, pause the video, and see if you can do this problem. Okay, the first derivative. I'm going to do the quotient rule. The quotient rule says the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, so what do I have on the top? I have x plus 2 minus x. Okay, this is all over the bottom. Now you can't cancel this x plus 2. You can't cancel one of those with that because there's 3 terms there. And in fact, on the top, you can see that those go away. And so your answer is 2 over x plus 2 squared. Okay, now when I go to do my second derivative, I have the top and I have the bottom. Now I am going to have to take the derivative of the bottom, but there's a squared there. So another way of writing the first derivative, there's nothing wrong with this answer, by the way, is to write 2 over and then FOIL that out. X squared plus 4x plus 4. So that's the same as that one. And this is going to help us find the next derivative. So there's the top there's the bottom. We're going to do the quotient rule now. So we've already found the first derivative. It's there. It's also there. And now we're going to find the second derivative, which says the derivative of the top, which is 0, times the bottom, which in some case, or in some sense, who cares what I write there because it's just times 0. Then we have minus the top, which is 2, times the derivative of the bottom. The derivative of the bottom happens to be 2x plus 4. This is all over the bottom squared. Okay. So this first part is just 0. I'm going to keep the top factored because there's nothing else on the top. I'm going to factor out, I believe I'll factor out a 2 from there. So watch this. I have negative 2, and then I factor out another 2. This is x plus 2. Now look at the bottom. This x squared plus 4x plus 4 is really, it's this right here, which is really this right here. So on the bottom, it's really x plus 2 squared squared, which is x plus 2 squared squared is to the 4th. And notice what we have on the top and the bottom. We have one term on the top, one term on the bottom, and those guys say, see you later. That 4 becomes a 3. So my final answer, negative 2 times 2, so that's negative 4 on the top, and on the bottom we have x plus 2 cubed, x plus 2 cubed. And that is 2 derivatives of our function. So we have our velocity function and our acceleration function. There's actually different interpretations of the first derivative and the second derivative, and we'll see that as we continue after exam 2. Let's go ahead and look at problem number 73. Now this problem 73 is not from 3.4, it's from the review exercises. So this is one where you are finding the tangent line at a point. And so look what we have here. So I'll do 2 problems like this, okay, where you're finding tangent lines at the point. Go ahead, pause the video, see if you can do this problem. Okay, to find the tangent line at a point, well, you need really a slope. And how do we get the slope? By taking the derivative. The derivative is the slope function. So the derivative of the first term is 6x, and the derivative of sine is cosine x. So here's the slope function, and I'm going to plug the x value into the slope function. If you're plugging the y value in, you're doing it wrong. You're like, oh, but it's 0. But, you know, another problem, this might say 0, 5, and you want to plug the first coordinate in. So I'm putting this in to see what the slope of the tangent line is going to be, and it looks like we have 0, 6 times 0, plus the cosine of 0. And then the cosine of 0 is 1. So this right here is the slope, and that right there is the point. So now I write y equals mx plus b. We know the slope is 1, so y equals x plus b. I'm going to plug the point in there to see what b is. 0 for y and 0 for x. Looks like b is 0. So my final answer then is going to be y equals x. And that is the equation of the tangent line at that point. I'm not going to go ahead and draw a picture or anything. We've done enough of that in the lectures. Let's go ahead and do another problem that's similar. Problem number 74, and I'm hitting you with the quotient rule again. Pause the video, find the tangent line at this point. Okay, to find the tangent line, you need a point, which we have. Here's our point. You also need slope? Well, I'm going to find out what the derivative is, because the derivative is the slope function. This right here is a quotient. So I'm going to do the quotient rule. The quotient rule says the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, let's continue this. Distribute the 4x squared plus 12, and then we have minus 8x squared. This is all over the bottom. So we have negative 4x squared plus 12 all over the bottom. Now, yes, it's true that I can factor out a 4. I can even factor out a negative 4, and then I would have like x squared minus 3, but it's x squared minus 3 and x squared plus 3, I mean, I can't cancel, so it's not going to help, but you can do that if you want. This right here is your slope function, and you're trying to find the tangent line. So let's go ahead and plug the x value, which is 1, into this and see what we end up getting. So on the top, I end up getting negative 4 times 1 squared, so this is negative 4 plus 12. And on the bottom, I end up getting 1 squared plus 3, which is 4. And this is squared. So on the top is 8, on the bottom is 16. 8 over 16 is 1/2. 1/2 is the slope. Okay, so we're going to bring it over here. We have y equals mx plus b. Y equals 1/2 x plus b. Let's plug in the point of 1, 1. So y is 1 and x is 1. And you can solve for b, and what you would end up getting for b, 1 minus 1/2 is 1/2. So my tangent line is y equals 1/2 x plus 1/2. And that completes problem number 74 from, I believe this is the review exercises. So now let's do some picture problems. These picture problems, you know, I was having a hard time figuring out how to do this. And so it's actually going to take up 2 pieces of paper. It says matching functions and derivatives. Match the functions a through d with the derivatives a through d. How confusing is that? Because you have like different letters of the alphabet. So you want to figure out what the derivative graphs of these look like. The derivative graphs are the slope graphs. So what I'm going to do is, I mean, here we have this right here. So we have, those are the derivatives. Okay. So what I'm going to do is I'm going to go ahead and just say, oh, what does this slope look like right here? What's the slope at each point on this line? It looks like, you know, maybe 1 or something. I don't know what it is. This is like, it looks like 1. So it looks like the slope here is 1. And because I don't have another piece of paper and I don't want to, it's gonna be more confusing this way. I'm going to actually draw the derivative on this graph. So the slope here is 1. We'll just say it's 1. And the slope here is 1. And the slope here is 1. And the slope here is 1. And it looks like the slope is 1 all the way to the point 2. So let me, I gotta get my ruler, which is on the other side of the room here. So it looks like the slope is constant 1 here until I hit x equals 2, and then look over here. This also looks like the slope is 1, 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 slope is 1. How many times am I going to say it? I don't know. And so it looks as if the slope is always 1. And at this point there should probably be a hole because the function is not differentiable at that point too. So what am I to do here? I'm going to look at the graphs and see if I get one that looks like that. And that is graph D. So, oops, we'll move both of them. The answer to this one is D. Okay, now we have something that looks like a parabola. And there's a hole there in that parabola, but let's just assume the hole is not there. If the hole was not there, then that would have slope of 0. So I'm going to put that right there, and we're going to assume that, we're going to pretend like the y-axis is the slope axis. And then right here, like at 3, this looks like it's a negative slope. Okay, so at 3 it looks like it's a negative slope. Maybe -2. And at 1 it looks like it's a positive slope, like a +2. And remember, with a parabola, the derivative of a parabola is a line, so this derivative graph's probably going to look like that, or something like that. And do we have any graph? We've already eliminated this one here. Do we have another one that looks like a line that has a hole there? Yes, that one right there. And of course, I forgot to put the hole there. Function is not differentiable at that hole, so I'll put a hole right there. And so this one right here looks like it. This is graph C. So C is the answer for this one. Okay, now for these guys here, it looks like for this one here, there is a, we have the tangent line right there. Almost looks like it is vertical. So it goes from vertical, and then it's positive and less positive and less positive and less positive. Sorry, am I saying less positive? Okay, so let's say the slope here is like 7, and then 6, and then 5, and then 4. So what you have, when you have a vertical slope, on the slope graph, you have something like that. And then right after x equals 2, you've got a very steep positive slope. So you're getting something that's coming from up here and coming down like that, because the slope is getting less and less, but it's always staying positive, so this will stay above the x-axis. Now, a little to the left of 2, you've got a slope that's very steep, but very positive still. And then it gets less positive as you go this way, so it almost looks as if the slope is going to go like that. But the slope is always going to stay, the slope graph will always stay above the x-axis, because the slope on this never looks to be negative. You're never going down on that graph. And so let's take a look at the graphs here. Do we have any that look like what we just did? Yes, graph B. And so by elimination, the last one has to be graph A. But on the test we should be prepared also to draw the graph of a derivative without matching. So we have another vertical tangent, so that's where the asymptote is going to be on the derivative graph. And then here the slope is negative, and here the slope is positive. So the slope right here is positive and getting higher and higher, so the graph kind of looks like this. And then here the slope is negative, like -1,000,000 right at 2.0001 or something like that. So it's going to be like this. And this will always be a negative slope, so it kind of goes like this, and then this one comes down here, and it doesn't cross the x-axis. And that's kind of what graph A looks like. It looks like that. So they just went in reverse order. Look at this. D, C, B, A. That would have been my second guess if I was just guessing this. Okay, so this comes right from, I think it's the review exercises, and that was number 81. Let's go ahead and we'll do one that is like this, which is number 82. Okay, so 82 says sketch the graph of f prime for the function f shown in the figure. And so what I'm going to do is, so it may have made some of you feel uncomfortable with me sketching it like right on the graph for those other ones, those other matching ones. And I have a little room down here. So I'll sketch it below. Here's x and here is y, which is really the slope, m. Okay, my first question is, where is the slope 0 on this graph? The slope is 0 at the bottom of valleys. So here's where the slope is 0. And the top of hills. So the slope is 0 right here. And the slope is 0 right there. So now, wherever I hit those points, like that's where the slope is 0. At that point, right here, we'll say they're the same points on the x-axis, there's going to be a point right here which kind of tells you that the slope is 0. You know, the y equals 0, that's the slope. The slope is 0. And then the slope is 0 right here. So let me go ahead and try to be a little precise about this. And the slope is 0 right here. Okay, let's go ahead and check out the slope here. So what's happening right here? The slope is very steep, and it seems to be, you know, like that almost seems to be, well, negative, doesn't it? Like that could be negative 100. And so the slope, like right down here, is coming from down here. So it's probably negative 100 on the y-axis, or maybe that's negative 10, I don't know. But what's happening is it's getting to be like negative 5 here, and then maybe negative 3 there, and negative 2, and negative 1, and then it goes up to 0. So it looks like as if my slope is coming up to that point. What happens after the point? If you start drawing tangent lines after the point, that slope is actually positive the whole time. And it goes up to about positive 1 or so. And so it kind of goes up like this. You know, here's where it's like positive 1. But then it starts getting less steep, and this is like 1/2 and 1/3 and 1/4. So it comes back down. Now you're saying, well, how high do I go, Joe? Well, this is just a rough sketch of the derivative graph. Then what happens after this hill here? Then the slope is negative again. The slope goes negative, but doesn't get really steep. It just kind of goes down and then goes back to 0. So the same thing's going to happen. We don't know where the bottom of the valley is, so we're just doing a rough sketch. And then what happens over here? Then the slope is like 1/2 and 1 and 2, and the slope is going to the stars, like 7, and then maybe over here like 100. So the slope is going up like that. And there is a rough sketch of the derivative. So hopefully, you know, those ones are a little uncomfortable. It's not as algebraic, but if you've been doing your homework, hopefully you've been doing problems like that. Let's go ahead and do a few more problems. This also comes from the review exercises. We're not going to do E and D because those are compositions of functions, and we have not studied that yet. That comes after 3.6. So let's go ahead and take the derivative of this right here, 5f plus 3 times g. So we're taking the derivative of that. So here's, let's just copy a down. So this is 84. Take the derivative. I'm kind of writing the notation a little different. 5f of x plus 3g of x. And we have x equals 1. Okay, so basically what you're doing is you're bringing that derivative in, and we have the constant multiple rule and all that stuff. What it's really going to be is it's going to be 5 times the derivative of the function evaluated at 1 plus 3 times the derivative of g of this function evaluated at 1 as well. So that's really what this means. It means take the derivative of this, and because we're just adding, the derivative of a sum is the sum of the derivatives, and then we also have the constant multiple rule, and this gets evaluated at 1. We're going to move this up here so we can try to see both things in the camera range. And so we have 5. Now this doesn't say f of 1, this says f prime of 1. Now f is in black ink, and here is f of 1 right here. So here's f of 1, which is 2, but they're saying the derivative, the slope at x equals 1. And the slope at x equals 1, if you look at the slope on this, the slope is 3. So f prime of 1 is 3 because I'm looking at the slope of that line. Rise over run. Look, rise, 1, 2, 3 over run. Plus 3 times, not g of 1, so here's g of 1 right here. G of 1 is 1. But they want the slope at that point on the g graph. And the slope there, you go rise over run, it looks like 1 over 2. So this is 1 over 2. 1/2. I don't know why I'm saying 1 over 2. Okay, so let's go ahead and finish this up here. We just have to do this calculation. So this equals this. This is 15 plus 3/2. This is, common denominator is 2, so 30 over 2 plus 3/2. So it looks like the answer to part A is 33 over 2. So that's how we do 84A. Okay, let's do 84B and C. Those ones might be a little more challenging. I need another piece of paper here. So 84, we'll just put the B there. So this is the derivative of a product. So we have the product rule for this. And then this notation right here says just put x equals 1 into that after you get it done. So the product rule says the derivative of the first times the second plus the first times the derivative of the second. So that's what the product rule says. But this, all the functions get evaluated at x equals 1. So f prime of 1, g of 1, f of 1, g prime of 1. And then you go to the picture to find out what those values are. We may have seen those values from the last problem. So f prime of 1, we already went over this actually. F prime of 1 is 3. And g of 1 is 1. Plus f of 1 is 2. So these guys right here are not slopes. They are just evaluating the graph. The primes are slopes. So g prime of 1, so at x equals 1, so the slope of that at 1 is 1/2. So what it looks like I have here, looks like I have 3 plus 1. The intense calculation, our results happen to be 4. Let's go ahead and finish up this problem by doing part C. And this problem is in your book in the review exercises. So, you know, if you want to look at the review exercises, you can. So 84C. This is the derivative of the quotient f over g evaluated at x equals 3. Okay, so this right here is the quotient rule. The derivative of the top. Of course, this is all evaluated now at x equals 3. So the derivative of the top times the bottom, evaluated at 3, minus the top, evaluated at 3, times the derivative of the bottom, evaluated at 3. This is all over the bottom squared. Of course, the bottom evaluated at 3 squared. Now this is going to be a little different because we're not evaluating the graph at 1, we're evaluating the graph at 3. So let's see if we can do this problem. Oh man, I'm running out of space here. I'm going to go like this. I'm going to fold this piece of paper right here. Boy, I'm very high tech. There it is. So that way we can see it all on the camera. I hope we can see it all on the camera. F prime of 3. Okay, so F prime of 3. So here's 3. F is the black graph. The slope of the black graph at x equals 3 looks like -2. So you do rise over run to get that. Then you're going to go G of 3. G of 3. I don't know what that is. I copied it and then that was on there. G of 3 is 2. We have minus from that. F of 3. F of 3 is 3. And then we have G prime of 3, so the slope of G is actually still 1/2 for the whole thing. So I'm going to put a 1/2 here. This is all over G of 3. G of 3 is 2 squared. Okay, so we're done with the graph. Go ahead and do the arithmetic on this. So on the top I have -4 minus 3/2. This is all over 4. I'm going to get a common denominator on the top. Multiply that one by 2 and 2, so this is going to be -8 minus 3. That's -11 over 2. All over 4 over 1. Copy, dot, flip, and my answer is -11 over 8. And that's how we do these ones with the picture on them. Let's go ahead and do another problem here. So this comes from the review exercises as well. I haven't been putting RE on this. Projectile on Mars. Suppose an object is fired vertically upward from the ground of Mars with an initial velocity of 96 feet per second. The height s in feet of the object above ground after t seconds is given by this function. Determine the instantaneous velocity of the object at t equals 1. So I guess what we want to do with this is figure out the velocity function. Okay, this is the position function, or the height function in this case. The velocity function is really the derivative. And the derivative of this is 96 minus 12t. So for part A, it says determine the instantaneous velocity, or that's just the velocity of the object at t equals 1. So this is 95. Here's A. So what you do is you go V of 1. V of 1 is 96 minus 12 times 1. 96 minus 12 is 80 something, I think it's 84, and we have to put our units. So don't forget on the exam to put your units. This is a velocity, so this is feet. And we look at, we see the units, sometimes they're meters and they're different units, but this is feet per second. So that's how you do that problem. I think this is a problem that is like the ones you might see from 3.6. B. When will the object have an instantaneous velocity of 12 feet per second? So here's your velocity function. 96 minus 12t. And they're asking in this problem, when? So you're trying to find the time, and you're going to set the velocity equal to 12. 12 equals 96 minus 12t. Okay, I'm going to go ahead and bring the negative 12t to the left-hand side, so I have 12t. I'm going to subtract 12 on both sides. I've already done 96 minus 12, so I know that's 84. And so it looks like for this one, I divide both sides by 12. 84 divided by 12, I believe, is 7. So it says, when will the object have a velocity of 12 feet per second? You won't just say 7, and you won't say t equals 7. I mean, you have to say 7 seconds. Of course, you can say t equals 7 seconds if you'd like. So there it is. What height, I'm not reading this correctly, what is the height of the object at the highest point of its trajectory? So the object, you're on Mars, and you've just, it says you're standing on the ground. Some problems you're shooting things off the cliff or whatever, and you throw an object up, and it comes back down. So it's asking, what is the height of the object at the highest point? Okay, so they want to know the maximum height. To find the maximum height, that is where the velocity is 0. And so it's kind of like the last problem. We put velocity 12 into this. So in part C, we want to put velocity 0 into this velocity function and find out, well, what time it reaches the highest point. And then this one says, what is the height? The battery on the camera just died, so now we're going to pick up. So we're going to find the time where the height is the highest point. So here's part C. This is velocity equals 96 minus 12t. And so when it reaches the highest point, it's not traveling up, it's not traveling down. That's where we say the bug is at rest. Let's set v equal to 0. And so, what do we have here? We have 12t equals 96. Divide both sides by 12 and you get t equals 8. And I believe that is 96 divided by 12 is 8. So, so it's 8 seconds, but that's not what they asked. They asked, what is the height of the object at the highest point of its trajectory? So what we're going to do with 8 is we are going to plug it into the height function or the position function. We're going to go s of 8. This is going to give us 96 times 8, so I'm plugging it in right there, minus 6 times 8 squared. Wish I had my calculator within reach. 48, 76. So I have 768 minus 64 times 6. I should just go get my calculator. 24, 36, 37, 38. 384. So 768 minus 384. I guess I'm being a math purist now. Borrow from the 7, there's an 8, 384. So this is 384. But they say, what is the height of the object? We're not just going to say 384, we're going to say 384 feet. Let's see what part D asks us to do. With what speed does the object strike the ground? Okay, So when the object strikes the ground, it's not when v is 0, it's when the position is 0. Okay, so let's see if we can fit this on here. There is the position function. I'm going to fold the paper so it says that. What speed does it? And it's asking actually the speed, so we want to be sure at the very end, if it happens to be a negative velocity, that we just take the positive part, because speed is different from velocity. Speed is the absolute value of the velocity, and so part D, that's when s equals 0. So we go up to this part right here and we say 0 equals 96t minus 6t squared. And I solve this equation. 6t squared equals 96t. Why did I do that? Okay, so let me bring everything to one side. 6t squared minus 96t equals 0. I'm going to factor out, I think, a 6. Does 6 go into 96? Yes, it does. 16 times. Okay. So we have 6, and then we have t squared minus 16. This equals 0. But that was kind of dumb. So what am I doing? Okay, so no one will even know. I don't even know how to factor today. Okay, get rid of that. We'll go over here. So this is true that 6 goes into 96 16 times. It's probably because I have the paper. You know, I'll try to make up any excuse. It's because the paper is folded. You know the excuse people make up nowadays? They go, it's the coronavirus. You know, it's like, hey, how come you guys don't have this on your shelf? And they're like, the coronavirus. Hey, how come you didn't give me change? Coin shortage. Why? Coronavirus. Hey, you were mean to me. Why? Oh, the coronavirus. So I can just blame that on the coronavirus. I factor out a 6t. So I have t minus 16. And then this gives me 0. So the 2 times where the height is 0 is at time 0, which makes sense since you're firing the object from the ground, and time 16. Now, what did it ask in this problem? It says, with what speed does the object strike the ground? I thought I could actually finish off this problem on this piece of paper. So they're asking the speed, and what you really need is the velocity. I'm going to go ahead and finish the problem off on this paper, which will be really annoying for some of you. So let's just take a look at this picture. This is time equals 0, and then over here we know, because I have time equals 0 and time equals 16, I'll go time equals 16 there. This is 16 seconds. So what I want to know is the velocity at 16 seconds. The velocity at 16 seconds, I'm going to go 96 minus 12 times 16. Okay, so I don't know which part of my lazy nature is going to win out. I mean, I want to do the calculator because I'm lazy, but then I don't want to walk across the room and get it. So I'm pathetic. 16. Remember the old days when you had to do that, and that was math class? Okay, so what is this? We have 96 minus 192. So this is going to give me a negative, what is it going to be? 96. So the velocity is negative 96 feet per second. But they say, what is the speed? So make sure you know that the speed is the absolute value of the velocity. So sure, it's negative 96 feet per second because it's going down, but the speed is 96 feet per second. And that answers part D. And so on this one, if you're looking back at the PDF, I'll just say see last page. Factorial, whatever. Okay. So let's go ahead, let's finish up this review. I know this review is going a little long, and at any time you can turn off the video and say, I've had enough, Joe, I can't stand this anymore, and that's all right. I'm going to cover bug 7, 8, and 9. On bug 7, I'm actually going to do a problem from bug 7, so you may have already done this problem. We'll run through this problem. We'll talk about speed, acceleration, speeding up, slowing down, neither, and then everything that was on problem 3 on bug 7. So I believe, let me just double check that that's what I'm doing. Yeah, problem 3 from bug 7, and I wrote it down in this sort of sloppy handwriting here. I'm going to make sure the camera is on. Good, and that it's in range. It's in range. It's good enough for government work. So, here's bug 7. Basically the setup, suppose the bug is moving along the number line. At time t seconds, his position is s, feet from the origin, let f of t equals s. So here it is. So, compute the velocity function. The velocity is just the derivative. So it's kind of like what we did in the last problem, except this is a bug on the number line. We're going to ask some interesting questions here. I'll do the problem in blue. I just feel like changing colors. V of t equals the derivative. So 3t squared minus 6t, and then there is a 0 there. So there's the answer to part A. Good thing we have derivative shortcuts. That is a very good thing. Where? Okay, so when they're asking where, they're asking a position. And if you want, you can call this right here, if you'd like, you can call this the position, S. That's what we've been calling the position. Where is the bug at -1 second? So they've given us the time. And basically, you don't even have to call that S. You could just say, I'm going to figure this out by going f of -1. So f of -1 is -1 cubed minus 3 times -1 squared minus 2. So this is -1. That's +1. So this is going to be -3 minus 2. So this gives me -6, where? Feet. So the bug is at -6 on the number line at -1 second. And -1 second means 1 second ago. What is the velocity at -1 second? So this obviously is v, and they give us the time, which is t. So part C, you're going v of -1, whereas in the last part we went s of -1 or f of -1, whatever you want to call that. So the velocity at -1 is 3 times -1, I'm plugging it into this function here, squared, minus 6 times -1. So this is going to be 3 plus 6. 9, and we have to put the correct unit on there. This is a velocity, so this is feet per second. So these are some standard problems with bugs. And in a calculus book, they would call this rectilinear motion. Let's do some more problems here. D and E. So here is your position function. Here is the velocity function that we put for answer A. When is the bug at velocity 24 feet per second? So when, we're looking for time. 24 feet per second, it tells you right there that that's v. So we are going to use the equation that has v's and t's in it. So this is the one that says v equals 3t squared minus 6t. So we replace the v with 24. I don't know why my spacing's so bad here. I should have left a lot of space for this, but oh well. So we have 3t squared minus 6t, and then that equals 24. We put 24 in for the velocity. This is a quadratic equation. I'm going to put everything on one side. So 0 equals 3t squared minus 6t minus 24. I'm going to divide everything in that equation by 3. So I have 0 equals t squared minus 2t minus 8. Factors of 8 that subtracting give you 2. I believe we can do that. So this will factor. Factors of 8 that have a difference of 2 would be 2 and 4, and we want a negative 2, so negative 4, positive 2. I set each of those factors equal to 0, and I get 2 times. I get the time of negative 2 and the time of 4. So when is the bug at velocity 24 feet per second? There's actually 2 times. At time negative 2 seconds, that's 2 seconds ago, and at 4 seconds. And so, we'll go like this to show that we kind of put the answer there. The next question says, where is the bug at velocity 24 feet per second? Well, where is the S or the F? So, this right here is S, and it tells you the velocity, and we know the times. There are 2 times when the bug is going 24 feet per second. That's a velocity going to the right. And so we want to put each of these 2 times into our position function. So the first one is a negative 2. So I'm getting the times right here, and we figured that out in the last part. F of negative 2 is negative 2 cubed minus 3 times negative 2 squared minus 2. This gives me negative 8. Oh boy. Okay, so that's going to be a positive 4. Positive 4 times negative 3 is minus 12. And then we have minus 2. So where's the bug at velocity 24 feet per second? Well, the first one's going to be negative 22. And then we'll put the units after we're done cranking out the other one. F of 4. So I put 4 into this function. 4 cubed minus 3 times 4 squared minus 2. I didn't put parentheses around because it was just a positive 4, so I can deal with that. We have 4 times 4 times 4. So 4 times 4 is 16 times 4 is 64. Then we have, this is 16 times 3. I think that's 48. We have minus 2. So it's really 64 minus 50. 64 minus 50. Can't believe I have to do this off to the side. That looks like it's 14 feet. Okay. So where is the bug at velocity 24 feet per second? Well, it happens that this would be at 22 feet, and that was at negative 2 seconds, and then 14 feet at 4 seconds. So that is the answer to part E. Okay, the next 2 parts, part F and part G. When is the bug at rest? Well, another thing that, and we didn't cover in this review, is sometimes they give you a function, they go, when does the graph have a horizontal tangent line? So you got to make sure you know how to do that, but it's the same as doing this one. It is when the velocity is 0. So when is a time, and then rest, this is telling you velocity is 0. So we go to this function right here. V equals 3t squared minus 6t. V is 0, and we're supposed to find what t is. And hopefully I factor this correctly, unlike the one I did earlier. I'm going to factor out a 3t. So this is going to give me a t minus 2. So I have 3t equals 0 and t minus 2 equals 0. So the 2 times would be time 0, time 2. So the bug is resting, which means he has velocity 0 at 0 seconds. That's that one there, and at 2 seconds. Where is the bug at rest? So we're supposed to put these times where happens to be, hey, with the position, that's S, and rest is velocity 0. So we already found out the time, 0 and 2. So what we have to do is we have to go F of 0 and F of 2. So let's do F of 0. Well, that's pretty simple to do. F of 0 is 0 cubed minus 3 times 0 squared minus 2. So this gives me negative 2. And then F of 2. So this is 2 cubed minus 3 times 2 squared minus 2. So this is 8 minus 12 minus 2. So this gives me negative 6. So where is the bug at rest, or where does the bug have velocity 0? That would be at negative 2 feet and negative 6 feet. Okay. Now here goes the next problem. Before we get to the what it asks, what I've done is I've taken some information from the previous parts of the problem, like we just had at 0 seconds. See, the position is negative 2 and the velocity is 0. So I went ahead and put all the things into a table so I don't have to keep plugging the same numbers into the functions. And I'm going to use that to answer some of these questions. It says, when is the bug traveling in the positive direction? Well, you may be able to kind of guess up here. We don't have all the information. The technical mathy way of doing this problem is you take the velocity function, which is 3t squared minus 6t. That's the velocity, a positive direction. That's when the velocity is greater than 0. So look at this. I'm going to factor out a 3t. And so I have t minus 2. This is greater than 0. So you might remember these problems from pre-calculus where you have a quadratic inequality. I'm going to go ahead and put those times on a number line, times 0, time 2. And then I'm going to go ahead and say, okay, so those are the zeros of the function. And I'm going to put some values in, like t equals 1. If I put t equals 1 in there, I have a positive times a negative, which makes a negative. T equals 50, that's a positive times a positive, which is a positive. And then t equals negative 1, which is negative, times negative, which is a positive. So this inequality is, we're looking at when this function is greater than 0 or when it's positive. So when is the bug traveling in the positive direction? That would be where the pluses are. So that would be when t is less than 0 or where the pluses are, where t is greater than 2. We'll just leave it like that. When is the bug traveling in the negative direction? Well, the negative direction is doing the same thing, except this says less than, and that's where you're going to look for the negative sign. That's between 0 seconds and 2 seconds. So a way of saying that is 0 is less than t is less than 2. So what are they asking us to do? They're asking us to draw a diagram for part J. So let's go ahead and draw a diagram. This is the good old bug diagram. Here's the number line. It's not that number line. This was like a time number line just to do that. Here is the official bug diagram. So when I draw this bug diagram, I want to note the resting times. Okay, the resting times, what color reminds you of resting? That's when the velocity is 0. That's right there. Right there. Rest. That's where V is 0. And that's where sometimes the bug turns around. So when you draw, let's see, the resting times, the positions would be -2 and -6. So I'm going to go like this. Here is -6, -5, -4, -3, -2. So the resting times, the first resting time is -2, and I'm going to put a dot there, and then -6. Okay, so when we draw the diagram, it does look pretty complicated, but think about this. When is the bug traveling in the positive direction? Anytime before 0. And so at time 0, anytime before 0, he's going this way, and at time 0, he turns around and starts traveling in the negative direction. So you're going to have a turnaround right here. And you're also going to have a turnaround at time 2, and at time 2 he's at -6. So you're going to have a turnaround right there. So I'm going to go ahead and turn the paper to the side so I can draw this a little nicer. So this describes the bug's motion. And look, at time -2, he's at -22, which is really off the graph, and he's going at a velocity of 24. And at -1 second, 1 second ago, he's at -6, and his velocity is 9. So he's still going positive, and then this right here is time 0. At time 0, he's at -2. He turns around, starts going in the negative direction, and then at time 2, so this is negative direction from 0 to 2. At time 2, where he's at -6 on the number line, he decides, I'm going to turn around and go in the positive direction. So from time 2 on, and he goes this way. And so the diagram looks like that. We can put more things on our diagram, but really you just have to have the turnaround times labeled at the correct positions on the number line as well. So that's what happens to the bug. This is his travels. He goes like this. He turns around, goes like this, and then turns around and goes like this. And of course it's all on the number line. Even though this thing's above the number line, it seems like it's going up and up and up. The bug is just staying on that number line. So he goes like this on the number line, turns around, goes like this, turns around, and goes like this. Woo! Okay, so we are almost done with this review. I think there's 2 more pages of problems here. The displacement, the average velocity, and the total distance traveled. So these are 3 classics. The displacement from -2 to 4. So the displacement from -2 to 4 is really f of the end time minus f of the start time. But because I have this, we've already plugged in f of 4 and f of -2, but f of 4 is, and this right here is f, by the way. Those are the same, f and s. So f of 4 is 14 minus f of -2. That's minus a -22. This gives me 36 feet. So that is the displacement in that time interval, which means at -2 seconds he's somewhere, and then at 4 seconds he's 36 feet to the right. That's what displacement is. So displacement can be a negative number as well. The average velocity from -2 to 4, well, that happens to be the displacement over the time. But we could write the fancy formula that says f of 4 minus f of -2, and on the bottom we have 4 minus a -2. Or you could just say, hey, we just found this, which is 36 feet, and the time interval looks like 6 seconds. So this gives me 6 something, what, feet per second. This is the average velocity, not to be confused with the instantaneous velocity, which we've been looking at. Average velocity just says that's what it is. It just takes a snapshot at the start time and a snapshot at the end time. And sometime the bug could be traveling different velocities if you're looking at the instantaneous within that time interval. Total distance traveled from -2 to 4. Well, this is now when you have to know your rest times. Are there any rest times within -2 to 4? Well, yes, there are. Remember how we circled this and we said there's a rest time there and there's a rest time there. So like if you didn't have the diagram that I showed on the last page, this is the correct way to do this. So what you would do is you would say total distance traveled is the displacement from -2 to the first rest time in that time interval. Then we have displacement from that rest time, so from 0 to the next rest time, which is 2, plus the displacement from this rest time of 2 to the end time of your interval here, which is 4. It just so happened in this time interval, it included both rest times. But if the time interval went from like -2 to 1, you wouldn't include this rest time. Now the other thing that needs to be adjusted on here is it's the absolute value, because some of those will be negative. Okay, displacement from -2 to 0, so I'm going to go f of 0 minus f of -2, absolute value, plus this one's going to be f of n times f of 2 minus f of 0. Okay. Just got a little confused, but I think just looking at things differently. And then this one is f of 4 minus f of 2. And good thing we have that chart up there, because we can find things really quickly. F of 0 is -2 minus f of -2. F of -2 is -22. Okay, f of 2 is -6. F of 0 is -2. F of 4 is 14. And then f of 2 is -6. Running out of room on the paper here, so this is 22 minus 2, which is 20. Absolute value of 20, which is really going to be 20. The next one's going to be -6 plus 2, which is -4. Absolute value of -4. And then this one's going to be 14 plus 6 is 20. So really you have 20 plus 20, that's 40. And then plus a 4, because that absolute value of -4 is 4. The only reason I'm talking this through is I'm running out of space here, so your final answer is 44 feet. Wow, so that was pretty dramatic. Now had we used this bug diagram, yes, we'd have to go a little further back, and by the time we were done counting, we would have counted 44 units, or 44 feet. So this way was actually more technical, more scientific, more accurate than counting 44 little spots on the number line. Okay, so I've added 4 more parts to this so we can cover the other 2 bugs, which would be, so I think we just covered bug 7, so this is bug 8 and bug 9. This shouldn't take that long. So what is the velocity at t equals 1? Well, the velocity at t equals 1 is v of 1, which actually was not on our table. And this is going to be 3 times 1 squared minus 6 times 1. So this is 3 minus 6. The answer is -3. -3 feet per second. I'll just put an S there because now I'm getting lazy. So there's the velocity at time equals 1. This is the instantaneous velocity. What is the speed at time equals 1? Well, the speed of 1, and I don't want to go s of 1 because then that would remind you of the position, so I just say speed of 1, is really the absolute value of that velocity. So it's just the positive part. It's 3 feet per second. Speed's going to make a lot more sense when the bug is walking on a wall instead of a number line, when he's walking in 2 dimensions instead of 1 dimension. And that happens in a later calculus class. What is the acceleration of the bug at time equals 1? Well, we don't even have the acceleration function. Let's go ahead and find the acceleration function by taking the derivative of the velocity. So the derivative of this is 6t minus 6. So the acceleration at 1 is going to be 6 minus 6, which is 0. We have to put the correct units, 0 feet per second squared. Now, is the bug speeding up, slowing down, or neither at t equals 1? So to figure this out, remember the quick way. It's velocity times acceleration. So our velocity times acceleration here is -3 times 0, which is 0. And if VA is 0, the answer is neither. I don't know if you remember that. If VA is positive, then that's speeding up. If VA is negative, that's slowing down. This concludes the review. I know we didn't cover every single little thing that you may have encountered in your homework, but we covered enough and probably too much in this review. Study hard. Have a good day.